Today on HYSKY Pod, we are thrilled to welcome Mikaël Cardinal. He's the Vice President of Program Management and Organ Delivery Systems at Unither Bioelectronics, a subsidiary of United Therapeutics. Mikaël is a leader in the fields of eVTOL, UAVs, and hydrogen aviation, especially for life-saving organ delivery missions. A mechanical engineer by training, Mikaël has been at the forefront of developing hydrogen-powered helicopters in collaboration with Robinson Helicopter under the vision of Martin Rothblatt. His work is redefining sustainable medical transport and pushing the boundaries of zero carbon aviation. I am so excited to dive into this journey of Project Proticity, the innovations and the future of hydrogen and aerospace. Mikaël, welcome to the HYSKY Pod.
Thank you, Danielle, and thanks for having me.
Yeah, absolutely. I want to start off by kind of talking about how you and I first crossed paths. And I knew that from the minute that I met you, you were a very serious engineer. And so we met, I think in 2020. Would you agree? Does that track?
That sounds about right. Yes.
And then we kept crossing paths at different events. And I know, when the whole eVTOL kind of craze and Kool-Aid, when people drank it in like 2018, 2019, 2020, there were a lot of people that kind of got in as sort of like, maybe this is like a get rich quick thing. It's hot. But you were one of the people that I identified as serious, and you were in it for the long run. Can you kind of talk about how you became interested in eVTOL and what that path sort of looked like for you?
Sure. So before joining Unither Bioelectronics, I was a business owner myself. I had a small company in Quebec, in the Montreal area, where basically I offered engineering services for people in aviation looking to modify their aircraft under typically a supplemental type certification process under Transport Canada civil aviation jurisdiction. So I was introduced actually to Dr. Martin Rothblatt, my current CEO at United Therapeutics, through some local business development people south of Montreal in the Eastern Townships area, more specifically in Bromont and Magog. It's the first time, it was the first time back then, that was in 2017, I believe, where I first heard about electric helicopters, right? And the eVTOL hype, and the Uber Elevate symposium, or I don't know how they call that back in the days, the Uber Elevate Summit, I believe it was called. So, we started to hear a bit more about the electric VTOL project. And first and foremost, I was really impressed about Dr. Martin Rothblatt's vision, and more specifically having a practical demonstrator flying, which was the first all-electric Robinson R44 that was converted from the piston engine like coming to 100% battery electric. So that was my first, I would say, eye-opening moment, that, okay, there's someone out there that is serious and that has a vision to bring those technologies within a very specific use case, that being organ delivery missions. And by the way, she demonstrated it. So I was immediately appealed to her as a young engineer, and a business owner, to team up with that kind of person to further the technology and hopefully commercialization. So this is kind of the origin story as it pertains to myself. And I joined Unither Bioelectronics, which is a wholly owned Canadian subsidiary of United Therapeutics. Shortly after, that was 2018, June 2018. And I now have the privilege to further the technology in the space of battery electric and hydrogen electric, as we all know, is super promising to increase the range and payload of those aircraft. So to your initial question, I think, there's several pieces and parts of the story, but long story short, I was brought in Unither Bioelectronics by Martine herself. to manage those various efforts, and more specifically, and now I'm very, very enthusiastic about the prospect of more specifically hydrogen as the primary source of energy to basically perform those organ delivery missions. Let me know if I missed any portion of your
No,
question.
that
I
that
think,
was that
yeah,
was great. And we'll talk more about Project Proticity in a
yeah.
minute, but I have to ask you, what was your first impression of Martine? Did you know her before? Did you know of her before you were introduced? I'm curious if your impression was similar to mine.
Yeah, no, not really. Back in 2017, I haven't read that much about her and her previous endeavors, such as Sirius XM. But I quickly realized that this person is definitely one of a kind in a generation, and that you want to be part of her journey, whatever form that takes. And for me, that was basically to use my engineering skills and resources to make a zero emission VTOL possible to save more lives.
Yeah.
Really.
Yeah, I couldn't agree more. It's so interesting because I had heard of Sirius XM. Obviously, it's the logo is in often almost every car.
Hmm.
I knew what it was, and same with Dean Kamen. I knew what the Segway was, but I didn't know the stories of the people that were behind these creations. And as you know, because I also met you with Rachel, my co-founder at our previous company, who's
Correct.
now Dr. Locks, medical doctor. And so we were trying to think of a way, I was really passionate about eVTOL and vertical flight, and we were looking at use cases that weren't just for the ultra rich. Like, how can we literally make the world a better place? And she was like, well, we can save lives, Danielle. We use helicopters in aviation all the time. I mean, we use helicopters in medical all the time. I'm like, that's exactly what we should be doing. So we were talking to Ben Marcus about this, and he's like, have you ever met Martine? So he introduces us to Martine, and it was like it felt like she was psychic, and it was kind of like you said, like you don't typically, it is once in a lifetime where you meet somebody with so many resources and could be doing anything that she wanted, but is investing her time and money into making the world better and sharing so many of the same values. We were just like, wait, I'm like, is this a dream? Do
Mhm.
you really exist? I felt that same way about Dean Kamen when I met him. And I remember you and I were at the flight. It was somewhere in California, an Air Force base. I can't remember which one.
As Los Alamitos Air Force.
Yes,
Yeah.
yes, where her and Rick piloted the battery powered
Mhm.
helicopter, the R-44, and everybody afterwards was drinking champagne. And I remember they were telling us not to go out there to the helicopter, but you and I both went out there separately. I just wanted to see um, was that extra were the fuel tanks being used for anything. And that was when I know I was like, I liked Mikaël because you were out there kind of like measuring and looking, and we were both looking, you're like, I wonder if we could fit hydrogen in here, which is exactly what I was thinking. And I was like, I love the way that they think on this team. And so I've kind of been like obsessing over your all story this whole entire time, because it's like every thought that I have, you guys do, and you actually make them happen. So it's just so exciting to watch. So
Indeed.
walk me through how Project Proticity started. My first memory is, when we were out there on the tarmac looking at the helicopter thinking, could hydrogen fit in here? Did it start before that? When did you guys officially announce Project Proticity?
Yeah, so great question. And yeah, definitely a lot of history in the making with that first battery electric helicopter flight. Um, so basically, I want to say first and foremost, Project Praticity is really a natural continuity of all the efforts in terms of technology development in that space that we did in the past, either in-house or teaming up with those external tier one and OEMs and even startup company like Biotechnologies. As you know, we have that collaboration as well. So I would say Project Proticity, technologically speaking, really started in 2016 when Martine was looking around for a team to make her vision a reality and demonstrating that, yes, we can actually do VTOL and be zero emission with electric, strictly speaking, electric power. Which he did, right? So Project Proticity, in terms of its origin story, really started in 2016, but it was basically unveiled more recently at the H2 Symposium from Vertical Flight Society in Long Beach. So Proticity in biology refers to the electrical current generated by the flow of protons, right? This same principle is at the heart of how hydrogen PEM fuel cells operate, just like those powering our hydrogen electric helicopter. So Proticity is a collaboration now between Unither Bioelectronics and Robinson Helicopter Company. We believe that teaming up with a solid OEM that has, close to and even exceeding, I believe, 14,000 helicopters manufactured to date, that's a key to commercial success on the long run. Having that expertise brought to the project is invaluable when you think about everything that has to be put in place from a manufacturing standpoint to achieve the consistency and the repeatability and the robustness of any aircraft design, right? So anyway, back to your original question, Proticity is just really the natural evolution of what Martine started back in the days in 2016. I must say that all the learnings that we've made with battery electric are currently leveraged for hydrogen electric, because as an engineer, you certainly know that we do need to hybridize the system for VTOL vehicles, giving the high power demand for the VTOL, right? So you have to have some level of companion battery pack capacity that complement the hydrogen fuel cell power for a very short amount of time for the transient regime. And this is exactly what Project Proticity is all about, using that hybridization. But hydrogen is the primary source of energy for 95% plus of the mission. And the battery system is only complementing that, the power for a very, very short amount of time for some corner cases where you have transient high power demand.
Sure. Yeah, we saw that as well at our previous company. I think it would be probably difficult to do just hydrogen fuel cells. I just want to touch on, you say 2016, and that feels like yesterday, but that's almost 10 years ago. That is very early, very early. And so that, that tracks, because it's like, I'll start hearing people in the industry talking about things. And then right when things kind of maybe seem like they're at that hype cycle of like, oh, this is what we want to do, boom, somebody attached to Martine or one of her subsidiaries or partners, they've done it. And I see that over and over again, where Beta was really early on in doing flights, really early on with their electric motors. You guys were early on with electric helicopters, and you guys have just been ahead of the curve on everything that you're doing. And I think that speaks to just Martine being a visionary and knowing that if, anything is possible, really anything is possible. Let's talk about, for, people watching this that maybe not know exactly what an organ delivery system is and why it's important. Let's talk about what United Therapeutics is doing and what they're doing with organs and why it's so important to have these vehicles.
Sure. So United Therapeutics is the only publicly traded biotechnology or pharmaceutical company to take the legal form of a public benefit corporation.
So it was the law of the United States for 200 years that any corporation that was incorporated, and most of them are incorporated in Delaware, most publicly traded companies are incorporated in Delaware, they must operate solely for the best interests of their shareholders. That's like the law. And so every time a company wanted to buy another company, and even if in buying them they were going to strip out all of the R&D and just milk them for their profits, the target company would go to Delaware and say, judges, block this hostile acquisition. And the judges would say, you know, I'd like to save the jobs here, but Delaware law is Delaware law. The shareholders only care about one thing, the highest price per share. This hostile acquirer is offering 50% above your share price. We have to order that you sell your company to the hostile acquirer. So this actually, the judges in Delaware and the legislators, they're good people, and it made them feel bad, okay? And so they got the Delaware legislature 7 years ago to write a new law. It says, if you want, you can incorporate in Delaware as what's called a public benefit company. And a public benefit is a company that nothing is more important than the shareholders' interest. So it's nothing is more important than shareholders' interest, but there can be a public benefit which is equal to the shareholders' interest. And in our case, the public benefit that is equal to the shareholders' interest is to create an unlimited supply of transplantable organs so nobody ever has to die on a transplant wait list. So we applied to Delaware. They said, well, United Therapeutics, you've already been publicly traded for 20 years. You're going to have to get a majority vote of BlackRock and Fidelity and Wellington and all these, you know, big funds that are our shareholders, not to mention thousands of individuals. So we sent out a mailing to all of the big shareholders, from the biggest in the country like BlackRock to individuals, and we said, we are going to run this company the same way we always have, but now in case somebody tried to take us over, they would have to demonstrate that they could do as much as we are to creating an unlimited supply of transplantable organs, and not just milk the company for the profits and zero out all the R&D. We got 97% of the shareholder votes. Again, Blackstone, BlackRock, Fidelity, all these huge funds, they all voted in favor of it because they said the way you make the most money and you have the most successful company is to do the best thing for the people, for the market.
So our public benefit purpose is focused on developing both novel pharmaceutical therapies and, on the other hand, technologies that expand the availability of transplantable organs and organ alternatives. So I'm going to get into the organ delivery system question in a few moments. So in addressing this purpose, that public benefit purpose, we also operate with an eye toward corporate responsibility, right? And that includes environmental sustainability. So we recognize that how we transport organs today is highly carbon intensive. It involves typically, Learjet, helicopters, ground vehicle as well. So as the company is developing those transplantable organs, either manufactured or alternative from the Xenotransplant program that is ongoing, there's going to be a lot of anticipated business need around how best to move these organs, keeping in mind that environmental sustainability that we believe has to be part of our corporate responsibility. So basically, in anticipation of that increase in the availability of transplantable organs, we think that we have to be consistent across the board by not putting more CO2 in the atmosphere. As a matter of fact, our patients ultimately are somehow very sensitive to air quality and pollution. So the nature of our mission and our corporate DNA really led us to come up with that, what we call the UTODS, or United Therapeutics Organ Delivery System program, which is really kind of the umbrella title that has basically multiple research and development parallel lanes, if you will. with all the purpose to deliver those organs at scale, A, zero emission, and B, optionally piloted. So the autonomous aspect of the mission is also very important for our business model, given that at scale, we want and we have the vision to reduce the dependency on the pilot resources. Pilot shortage is a real thing right now. So that's kind of the background and the why. So the organ delivery system that I'm responsible of is really a combination of different vehicles technologies that will have the capacity to serve portions of the organ delivery network. The organ delivery network that we are currently developing is basically a few centralized organ manufacturing location where UT intends to produce those organs, whether those organs are from genetically modified pigs, whether those organs are totally artificial, meaning like 3D bioprinted, for example.
Which is possible for
Which
those
is
that don't know.
possible.
I
Yes.
actually
Yeah.
saw the 3D printed lung that Martine presented, I think in 2022. I couldn't believe it. She did,
I
it was
believe that was at the Life Itself
yeah,
conference.
life itself. Yep. If they do that again, you must attend. That was a
Yeah.
really cool conference.
Yeah. So a few of these centralized organ manufacturing location to all those transplant centers in need of those life-saving organs is really how we are currently shaping the concept of operation. So we have again multiple type of vehicles. We have the Beta Alia aircraft. We're now developing the technology for hydrogen electric using the Robinson airframe. We also have last mile delivery solution to serve, for example, airport to hospital, right? To that extent, in 2021, on a side note, my team did the world's first drone delivery of a lung for a human transplant in Toronto back in September 2021. So all these vehicles really converge towards a 100%, zero emission, optionally piloted, so some level of autonomy all across the network end to end. So that's the vision, and that's a vision led by Martine, and we run with it and we make it a reality.
I love it. I mean, it's just such a good thing that the world needs. For somebody to need an organ and not be able to receive it, for many of the reasons that Martine discussed at Life Itself, that it's a problem that is fixable, a challenging one, but I just love how she takes on the biggest challenges and then makes them come to life. Something that is interesting to me, because I know you guys worked with like eHong for a little bit. I don't know if you still are working with them, but I remember asking Martine the day I met her, actually, she showed me a video, and Sarah was in it. I think you actually might have flew in the eHong eVTOL. Sarah is Mikaël's wife, by the way. You guys are nice, so nice people. You must tell her I said hi. But so I remember seeing the video where she was, I guess, acting as like a doctor or a medical professional. She took the organ and went into the eVTOL, and then it flew with it to the hospital. And I asked Martine, do you need to have a human there? Because you could do it. It would be a lot easier to do it if you didn't need to have like that 200-pound extra, weight for the human. And she said that I will not. That's a life, and I will not send it without a human there. Do you guys still hold that value? And this is going to be kind of a loaded question. Do you still need to have a human on there? And then also, as a follow-up, I was reading, this Proticity flight that you did actually a month ago today. It was March 27th. So congrats, 1 month
Thank you.
anniversary. was an R44, but then I was reading you wanted to go to the R66 because it was 200 more pounds payload. What are those 200? I think it's 2,900 pounds or 2,700 pounds total.
2,700 MTOW.
Yeah, if the mission is to deliver, I'm asking a lot of questions, so you can just fill in what you can. But if the mission is to deliver an organ, and at least one human, what do you need all of those extra pounds for? Is that so it could have like multiple use cases and maybe do like air taxi missions or emergency search and rescue? What are those extra? What's that extra payload for?
Yeah, all good questions. So to your initial remark on uncrewed versus crewed flights, I think that to build a safety case, and that's really my personal opinion, right? So to build a safety case, you will have to demonstrate that with novel technology, you can repeatedly, safely, consistently, in a robust and reliable manner, do the same mission over and over again, right? Whether that's hydrogen, whether that's some level of autonomy, whether that's battery electric, hydrogen electric, whatever. I think there's going to be a transition toward fully autonomous flight and therefore not requiring a pilot on board further down the line. But that will have to be based on the initial pilot on board, pilot in the loop or human in the loop concept of operation. So we've always promoted the optionally piloted specification under our UTODS or UTODS program. Once we get into FAA clearance for doing the same mission, once the safety case is built and accepted by the authorities, I think that at this point, we can consider, for example, having multiple organ care systems on a single flight. So that 200 pound from the pilot is replaced with an actual useful payload that is being delivered to save a life. And given that the origin of those manufactured organs is well known in the future, it's going to be easier to do that as opposed to donor organs that are a bit random in terms of origin, right? So I think the nature of the business that we're building under United Therapeutics broadly will allow us to implement multiple organ delivery mission with a single vehicle once we get to higher payload capacity. Now, in terms of the, I think you had a question around, okay, so autonomy, pilot on board, crewed, uncrewed flight. I think that tackles your initial question. Can you just repeat your second?
Yeah, well, I was saying, like, what would you need the extra payload for, like 20, I don't remember, 2,700 or 2,900 pounds, but I think you did sort of answer it that you could do more organs in one flight. I think
Right.
you answered it. So,
Okay, cool.
Yeah.
So let me add a bit more colors on the upcoming pivot to the Robinson R66. As you may have seen from the proof of concept flight that happened 1 month ago, the current state-of-the-art PEM fuel cell system, and especially the balance of plant component in terms of volumetric density, right, is quite a challenge in terms of how to integrate that onto a small normal category Part 27 helicopter. So the R44 currently is certified all the way up to 2,500 pound maximum takeoff weight. The Robinson R66 has that 200 extra that allows for either more hydrogen or more useful payload, right? So you always trade range and payload figures. So very appealing to us to pursue the program for that Proticity project using the R66. And as you pointed out, the 200 pound extra as well, you know, is all good margin for payload and or range, right?
Got it.
So also I would say that in terms of the balance of plant component, the R66 or Robinson R66 has more volume available to avoid affecting the OEM outer motor line or OML shape, and therefore the lift to drag ratio of the helicopter will be maintained the same ultimately for the R66 hydrogen electric. So this is really what led us to the selection of the R66, I would say. However, I want to say, the R44 and R66 are very similar airframes. So in terms of, how it flies, and then in terms of operational procedures, et cetera, it's very similar. It's just kind of a situation where you have a bit more volume, a bit more extra MTOW to accommodate more hydrogen or payload. So it made a lot of sense to us pursuing that option for the hydrogen electric next phase of development under project.
Yeah, that makes a lot of sense. And then I could see, and I think in the Vertical Flight Society article, which shout out Vertical Flight Society and Mike Hirschberg for breaking this story. It was a fascinating read. I think they broke several of United Therapeutics. Getting a notification. Okay, for some reason it was asking me a language thing. But shout out Vertical Flight Society for all of the work and coverage that they've done on UT and UB. I don't say it as nice as you. I grew up in the Midwest, so it's just Unither Bioelectronics. I'm not going to try to pronounce the French way because I'll butcher it.
That's fine. We have two legal names, English and French.
Awesome. But I could see the R66 version being certified to be used in like an eVTOL like beta. It's probably matches more. So it sounded like that's sort of what you guys plan to do. I was reading that if that system was put in, which by the way, the beta Alea can fly 250 nautical miles with batteries alone, which is huge. That's groundbreaking in itself, and that's because it's got the wings and much better lift. But if you were to put the hydrogen system on that aircraft, it could go 750 miles.
Oh yeah, and even more than that. Yeah, 700 bare minimum. So I believe that demonstrating the technology on traditional airframe, and then in the future moving on with more novel, more optimized airframe is one of the approaches. I think that makes sense. And yeah, definitely having a higher L over D will help going farther and having more flight time. But I must say that from a certification standpoint, the multiple shots on same goal philosophy that we have across the board at Unither is really, how we work in different areas, but converging with the same goal, right?
Yeah.
And I think that the approach of using traditional airframe or already type design airframe and converting them and certifying them under a supplemental type certificate process is one of the promising solution to get to the market sooner than later. And of course, all those learnings and all the making of the standards or the authority recognized design standards and perhaps some policy making that will have to happen to make hydrogen aviation a reality. All those initial efforts will definitely push the industry forward, including, more novel type of airframe going forward.
Yeah, and that's what we see. I think a lot of people doing zero avia, for example, retrofitting. It definitely, you don't need to do all of it at once. You have certain people like Beta working on the airframe, and then you've got people working on the supplemental type certifications, which I think is really important. It's going to be a lot easier to do it on an existing, already certified aircraft. So really smart the way you guys are approaching it. Here's a question that I just thought of that I didn't think I would consider, but it came up and I want to ask it. What do you think, or do you think that now I know you guys are based in Canada, but you do a lot of things in the United States. do you think the new administration in the United States will affect how hydrogen aviation is viewed? Do you think it will affect it? Do you think it will affect it negatively or positively? And what do you think we should maybe do in the US during this time?
Yeah, that's a good question. First and foremost, I think that the development activities of such technology has to happen in a place where you have local green hydrogen production, and more specifically liquid hydrogen production expertise. And we do have that currently in Canada, 30 minutes away from the research and development facility that I lead under Unither Bioelectronics. So from a development perspective, I think the next few years, very promising for us. So we do have that local expertise and we can leverage that. And it's really in the product development cycle phase, right? Now for commercial flights, and when you look at the future infrastructures need, for example, and the hydrogen economy across North America, I mean, I like to stay away from politics, but it's nonetheless, I think when people will appreciate the performance of the technology, the environmental benefit of the technology, and the safety of the technology, and finally, I would say the reduce direct operating cost, because the mechanical system is simpler. Fuel cell stack, no moving part, for example. Of course, there might be some additional maintenance required for the storage system, the hydrogen storage system, but I don't think that's going to be dramatically different from the current maintenance workload that any operators of helicopters are currently operating. So I think that all those factors considered will convince people that hydrogen has to be part of our economy, and whether administration X is there or Y. I think this is where the industry needs to push, and especially in aviation. And I think that hydrogen has been clearly identified as one of the key solutions to enable that 2050 goal set out by ICAO. So, we believe that we have a very nice use case that could be a catalyst to demonstrate the benefit of the technology from those various perspectives, and therefore convincing more people to embark the journey, including airport, at scale. So this is how I want to see, or how I like to see it.
I agree. I think that it's just inevitable that the industry goes in this direction, regardless of who's leading what. Because from a mathematical standpoint, what got me interested in a hydrogen is that when I was in college, one of our design projects in aerospace engineering was that we had to fly. It was a high altitude UAV, and I think now they call them HAPS, high altitude performance systems, but same thing. It's like a kind of like a low Earth satellite sort of thing.
Yep.
And it needed to be in flight for, it was like 3 or 4 days. I think initially it was like 7 days without stopping, but then it was like 3 or 4 days, but you could have 2 aircraft. And it couldn't have any carbon emissions. And like I said, I had to fly for a really long time. Well, I was on the power and propulsions team. And so, first thing I did was look at batteries, and there were a few of us on that team, and we were we went in completely blind. It was like our first design project. So we're researching everything you could possibly imagine of fuel types, terrible ones and good ones. And so we did this for 6 months, and we converged to hydrogen. That was the first time that I not discovered, but personally, that I realized what hydrogen was possible of. And then it was funny because we were competing with other teams, and the other teams found out that we had figured it out, and then everybody converged to hydrogen after that. So that was the first time. Then another time I was on a design project, similar mission, not as long, but no carbon emissions. We converged to hydrogen. And then a third time in the eVTOL space, we were doing the math, we converged to hydrogen. So I think anybody that's been on a power and propulsions team with the goal of not having carbon emissions will inevitably, the math is going to lead you to hydrogen every time. What do you say to naysayers? There are a few out there, and there are some with batteries as well, eVTOL, air taxis. But what do you say to naysayers when, folks that think, hydrogen is too dangerous or it's not possible or the boil off, or what do you say to that?
Yeah. I think one very, very credible source out there in the context of using PEM fuel cell for hydrogen eVTOL aircraft is a NASA contractor report drafted by Professor Data from the University of Maryland, Gesso Rotorcraft Center, Research Center. The key takeaways, as well explained in that report, that will make hydrogen eVTOL aircraft very competitive in the market.
Yep.
And more specifically, in that report, they used a light normal category rotorcraft as one of the baseline models. So that's obviously very close to what my team is currently doing with the 44 and the R66. So the number one takeaway from that report is that we need to make that a reality and a competitive product, an efficient tank storage system of at least 15% weight fraction of hydrogen at minimum.
Mm-hmm.
We believe that we are on good course to 2x that figure with hydrogen storage we're developing with our business partners. The number two takeaway was that, if I recall correctly, the fuel cell stack system has to have a specific power of 1.1 kilowatt per kg at system level, so net power density.
Mm-hmm.
Or net available power density. So that's basically the available output power from the fuel cell when you have the total power less or minus the power required to feed the balance of plant components such as the compressor, etc., divided by the overall system level total weight of the fuel cell. So I think we are shy of that 1.1 kilowatt effective per kg net power density figure currently, but in the next 2 to 3 years, we have intel in the market that the industry will get there sooner than later. So I think that from a 30,000 feet perspective, there's a lot of upside potential in the areas of hydrogen storage efficiency and fuel cell system improvement. And therefore, that will directly translate into a very, very appealing VTOL aircraft design going forward. So the naysayers out there may say, okay, fuel cell system, balance of plant, that's heavy, there's the liquid cooling and it's a complex system. It has to be well conditioned. What about, variation in altitude? What about the compressor and the humidity of the air and all that? So we believe all those problems are just noise and that it can be solved quite easily. But fundamentally, our approach relies really on that specific power upside potential for the fuel cell system improvement in the next few years only.
Yeah.
That's super promising. And I'm even not talking about high temperature fuel cell. I'm just talking about improvement on low temp and intermediate temp stacks system. So, these are my thoughts. I think from a safety perspective, there's a lot of very positive argument that basically support the added safety benefit of hydrogen versus, for example, avgas or jet fuel. But true, hydrogen is highly flammable, and we need to properly integrate the high voltage system to avoid any, ignition of any hydrogen that would have leaked, for example, in some connection or reliefs. But that's something that can be mitigated very well. By good system integration, best practices, and B, by some additional operational abnormal and emergency procedures, which is actually exactly what we're currently doing for the proof of concept in Canada with the helicopter. So really, there's a lot of benefits. We recognize there's a lot of downside of hydrogen from a safety perspective, but the downsides can be addressed. And at the end of the day, we believe that hydrogen can be equal or safer than jet fuel within the context of our helicopter conversion to hydrogen electric.
I couldn't agree more. And I'm so happy that you brought up Dr. Anubhav data. Huge shout out, Anubhav, because it's funny. Some people say, how do you know what United Therapeutics and Mikaël and Unither Bioelectronics is working on? I'm like, I'm assuming that Mikaël has studied this report because he's literally doing exactly what it says. By the way, as somebody that studied that report, I'm like, they're doing it. It's so cool because Anubhav literally wrote the roadmap for what somebody needs to do if they wanted to fly with hydrogen. That report, I reference it so often. So I'm just really happy that you brought it up because that was such a big contribution that he gave to the industry with NASA. That's my go-to expert. I think he's a lot of go-to experts. So I just wanted to give him a shout out. He's somebody I should get on the podcast sometime just to talk about kind of what inspired him. But, another thing I'll just add to your point is I couldn't agree more. These challenges are things that we've solved in engineering a long time ago. We have flown with hydrogen. Some people don't realize how often we have flown with hydrogen. We use fuel cells all the time. They're used in forklifts, they're in cars. So yeah, it's true that we haven't. Yeah, exactly. In space, and they're used in space. So people talk about, oh, there's differences in altitudes. We literally send them to space. We've used liquid hydrogen as rocket fuel. We've also used them to to power fuel cells in space. So these are things that it's not new. The idea of using hydrogen in aviation or aerospace. In fact, the Department of Energy, I think it was 2 years ago, almost 2 years ago, put out the North America or the United States roadmap for hydrogen. And I'm not saying the title exactly, but something like that. They put out a roadmap. And the very first sentence, they talked about how we used hydrogen in aerospace. And the rest of the paper didn't talk much about aviation and aerospace, but I was like, you can't talk about hydrogen's history without talking about space and aviation. So for people that think it's just so crazy, harebrained idea, it's something we've been doing. It's had a lot of what I would call negative propaganda around it that, it's so dangerous. Yes, it is flammable, but these are things that can be mitigated. So
yeah, definitely. Yeah, I think back to the safety aspect of your question. I think people have obviously that Hindenburg, early century Hindenburg accident. The technology we're talking about here is completely different. Liquid hydrogen on a vehicle is vacuum insulated. There are several safety relief devices for instance, and the type of technology is completely different. The hydrogen is contained in a completely different structural element and is isolated from the outside environment by vacuum and so on and so forth. So, I mean, I think there's a lot of education, to your point, that maybe has to happen from a safety standpoint. I think, you made a very good point. We've been flying hydrogen for for so many decades now, and it's not a recent thing. The new element is the application of hydrogen for general aviation and perhaps commercial aviation, airliners and so on and so forth by 2050. So I think the safety aspect of hydrogen is a matter of good engineering and public education and regulators education as well. Because hydrogen, of course, has not been certified for aviation, right? So we need to agree on a authority recognized standard for such system that will result in a equivalent level of safety that is equal or greater, right, compared to avgas or jet fuel. So really trying to align the technology development with a safety level that is well aligned with the FAA safety continuum that is currently the standard.
Yeah, I wasn't going to bring up the H word, not hydrogen, but
Yeah.
the Hindenburg.
Yeah.
But since you brought it up,
You can cut it from the podcast.
yeah, no, it's good. We actually sell a T-shirt that it says hydrogen did not cause the Hindenburg to blow up, and then it has like a little kind of straight face emoji, but the face is a hydrogen molecule. It's like my favorite shirt. Yeah.
I love it. I want one.
Yeah, I'll send you the link. I've worn it so much that it's a green T-shirt. The green is almost yellow now because I wear it so much, but I need to get a new one. But to that point, first, we flew with hydrogen in dirigibles before the Hindenburg and after. But something that I want to bring up with almost all, I'm hesitant to say every single one, but I'm going to say almost every unnatural disaster was caused by humans, usually in leadership, that have a lot of money on the line, not listening to engineers. The Challenger is an example. There's lots of reports and documentaries you can read on the Challenger, not related to hydrogen, but just to my point, where the engineers were saying there was a problem with the O-rings, and because it was so publicized, leadership said, we need to fly, we need to launch. The result was catastrophic, and the whole world saw. Similar happened with the Hindenburg. So what a lot of people don't know, I'm such a nerd on this topic. I have 2 books, and I just found out that there's a third one that debunk what the public story was on the Hindenburg. And actually, they added in audio later. So the audio of like people screaming and saying things, that's not on the original video. And there was some weather happening, some lightning, and I don't remember who, maybe, I don't know, whatever the air traffic control was at the time, was urging them not to take the flight because there was some lightning. And the pilot or captain, I don't know what they're called, did like a hard pivot at a turn that they also advised not to do. So they were advised not to fly until after the storm, and they were advised not to go this certain way. So they deviated from the path and ran into lightning. And that story is just not told. So like you said, yes, hydrogen is flammable, but if the directions were followed, then it probably wouldn't have happened. And unfortunately, hydrogen was blamed for, people trying to meet deadlines and the bottom line and not listening to professionals. So, I think it's the same thing as like, if we listen to what people like you are saying, the engineers are saying, like, it's safe to fly under these conditions, and we follow those things, and we can avoid a lot of those disasters. So, I encourage people to look into that.
Yeah. No, that's a good point. I think from an engineering perspective, it's all about making sure that your engineers are in full understanding of the failure modes, and based on those on this knowledge of the failure modes of the system, what are the mitigations by design or by operational procedure that you're putting in place, even at the product development level. So my team is doing that, and we have a a safety management system as well on top of that that captures any occurrence during ground testing, for example. And we're building a database that is specific to how the hydrogen system is integrated onto the helicopter. And we learn from those different failure modes, either by analysis or in a low-risk environment, such as ground test bench, right? And we feed that into the actual vehicle design going forward. And for each of those failure modes, again, we have a comprehensive approach in terms of how to mitigate that to meet the ultimately the safety requirement for certification.
And I think it's so important that your team, because United Therapeutics is a life-saving company, as engineers, sometimes we can forget that, we're messing with machines and voltages, and we can kind of lose sight of like, there's going to be a human in this. But since your team, your core company is based on saving lives, like it was important for me to hear Martine say that's a human life. In that sometimes as engineers, we kind of tend to lose sight of that. We get excited to, see something work. And of course, safety first. But sometimes it's just, I know a lot of engineers with missing body parts, from doing experiments. So I think, just with your guys' values, that really helps, because not many aviation companies come out of the medical field. So I think that just adds another layer of awareness to what you all are doing.
Yeah, that's a good point. I mean, we are obviously a patient-focused company. So whether, we have people working on the science of xenotransplantation, whether we're working on a novel way to deliver those organs with a sustainable aviation solution, like what my team is doing with hydrogen, really, throughout the UT business, we obviously have that patient first or patient centric approach, and we make sure that all employees are really getting that DNA early on when we do hires or so on and so forth. That is really what dictates all our efforts, and the fundamental why, as Simon Sinek would say, fundamentally the why of we're doing all that. So obviously a patient first, patient centric company dictates everything, even how we see the development and the actual implementation from an engineering perspective or flight operation perspective as well.
Yeah, it's so important. I said not very many aviation systems come out of medical, but I venture to say you all are the only one. As somebody that came out of manufacturing and worked on big company aircraft, a lot of times the bottom line is the most important. It's get the aircraft out the door. We need to sell this many per week, no matter what. And we see the result of that in the news. So it's really, I think, going to shift, especially right now. People's perception of aviation is not great. And that's aviation's fault, So I think where you guys are coming from, maybe it's just a consequence, a good way, a benefit of the way you're formed, is that, it started with saving lives, and then, okay, we need sustainable aviation, but with the goal not just being to fly from A to B, but to save a life. Maybe that's how all of aviation needs to be thought about, because it's just really cool. I mean, I never even thought about like that before, but you guys are the only company. I can't think of another aviation company that was derived from a life-saving mission. Can you?
Yeah, well, I certainly don't know all the companies out there, but I think the United Therapeutics environment is a unique environment, and we have a unique outlook, I would say, both from an aviation and biotechnology perspective, that will actually contribute to saving more lives going forward, for sure. I would agree with you. It's quite a unique environment quite a unique environment, and I think throughout the process, although we are a bit out of the box in terms of how we do things and what and where, I think it's also important to bringing the wisdom and knowledge of well-established OEMs, such as Robinson Helicopter Company.
Yeah.
So I see our company as a catalyst for those new technologies, and having a type of a skunk work teams, in-house, and then but supported with outside OEMs like Robinson Helicopter Company to accelerate the development and leverage those decades of learnings,
Yeah.
are very, very valuable for what we're trying to achieve. And of course, safety is paramount here. I think the nature of the use case, the UT use case, is definitely a catalyst to demonstrate the safety and the benefits of using such technology in the national airspace.
Yeah, I think it's potentially going to reshape how the world approaches aviation, and it's so desperately needed. In fact, so I quit my manufacturing aerospace engineering job around this time period when we were seeing a lot of negative things on the news. I was directly involved in that, and I just said, this is not why I became an aerospace engineer. I don't want any part of that. And that's when I really started looking at other ways to do things and eVTOLs and saving lives, which is around the time that I met Martine. And I told Martine this too. I was at a point where I didn't even want to be involved in aviation anymore, unless it was done differently. And so I met her at a time that was so critical. Had I not met her, I probably wouldn't even still be in aviation, because I was just so turned off by what the industry was doing and some of the decisions that were being made. So I'm just so grateful that you and her are doing everything that you do. I want to kind of pivot.
Thanks to you, and maybe if I can, thanks to you for all your effort with HYSKY. I think you are a very thoughtful leader in the space, and we need your work to help companies like UT meeting their business goals ultimately. So yeah, thank you for that. You're part of it.
Oh,
well,
sure. Thank you. Thank you. You guys give me a reason to get up in the morning, and I love to talk. And so that's one of, I didn't think anybody would ever be interested in the things that I like to talk about. And it just happens to be the synergy. So any way that I can, sort of pollinate flowers and spread the word, that's what I want to do. And you guys make it very easy, because I just find things that I'm interested in, and it just happens to always be attached to you. So it's it's very easy. Yeah, so I want to kind of pivot. You said a couple of words that the audience may not be familiar with, and I'm still sort of understanding this, but you talked about I think everybody sort of gets the idea of 3D printing organs. But you said xenotransplantation. And then you mentioned pig. And every time I hear that, there's always a weird reaction in my body, wait, pig. And I kind of understand that, but could you explain in just as basic terms and lay terms as possible, what is xenotransplantation? Where do the pigs come in, and what purpose do they serve? And how does that lead to 3D printing, or is that something totally separate?
Yeah. So first and foremost, I'm not the expert on organ manufacturing.
Which is why I want to ask
really
you,
on
because you'll probably explain it in a way that I can understand.
So basically, xenotransplantation refers to explanting an organ from one species and transplanting into another species. So that's animal to human. So to that extent, we have a team in Virginia that is working on the modification of the pig genome to make it closer, if you will, to what the human recipient needs. Ultimately, whether that's a kidney, a heart, or so on, and so forth. So we have that team in Virginia that is developing the science of that xenotransplantation process from the pig farm all the way to the actual transplant center.
I have a question. Sorry to interrupt, but why a pig? Does a pig just happen to have organs the most similar to a human?
Yeah, the pig genome is close enough to
Okay.
human. Yeah, so it's one of the options that basically results in less rejection rates.
Hmm.
So by modifying a number of genes of that specific animal, the company is able to demonstrate that the organ is actually in a much uh, higher state of chances, if you will, to succeed in a human transplant procedure. So we have, by the way, in Christiansburg, Virginia, the world's first what we call a designated pathogen-free facility,
Hmm.
where the pigs or the piglets are hosted for, I believe it's a couple of months. They are put on a very special diet. They are breathing very clean air,
Hmm.
clean water, pathogen-free environment before the explant procedure.
Hmm.
So this is a facility that is currently sitting in Christiansburg, Virginia. It's a good example of the company commitment to further the science of xenotransplantation.
Hmm.
And that's even not related to 3D bioprinted organs, right?
I see.
Where we are actually building the scaffold of a lung, for example, in a lab, and then cellularizing that scaffold with the patient's own stem cells,
So cool.
which basically is another way to increase the availability of transplantable organs in the future.
I see.
Of course, those are all investigational programs.
Hmm.
So this is currently not FDA approved. These are
Hmm.
all investigational programs,
Hmm.
and we are starting with the xenotransplant uh, xenotransplant program in the first place because this has much more maturity than the other forms of alternatives
I
or
see.
organ alternatives, such as 3D bioprinted. There's a lot of variants on all those organs. There's ways, for example, you can take an animal organ and then decell and then recell with human cells, right?
Mm.
So there's several ways that the company is investigating all those various organs. Ultimately, I think this is going to result in a dramatic um, change. It's a game changer
Hmm.
for all those patients that are currently waiting on the transplant list, which is well above, I believe, 115,000 in the US. And that's not even counting those patients that are not eligible to get on that list.
Mm.
So the numbers are just, much bigger than the published list of waiting patients,
It's
because it doesn't consider those patients that are not eligible to get on that list.
Yeah, it's interesting. Earlier, I mentioned that I asked you if you had heard of Martine, and I mentioned that I hadn't heard of her before meeting and learning about the eVTOL stuff. But something that was interesting was I was at an event for like some parents of children that needed organs. Those people knew who Martine was. Um, yeah, so I thought that was very interesting. They knew who she was. Another thing you said earlier, I think I'm probably gonna mess this up, but I think you said like one goal, multi shots when we were talking about like the aviation side of things. So correct me if I'm wrong, but the xenotransplantation and the 3D printing, are they just multi shots of the same goal? So they're just different pathways that maybe could work.
Exactly. Yeah, these
Okay, I
are
get
all
it now.
pathways that we believe it can work. If they all work, well, that's a plus, right?
Yep,
Because
I get
because
it. You're just
ultimately
increasing
that
the
results
odds.
in more offer for the
Hmm.
waiting patients. But yeah, several shots on the goal of expanding
Got it.
the availability of transplantable organs.
See, that's why I needed somebody that wasn't an expert. Because I've been asking that question for a couple of years, and I just needed that simple, like it's just different ways to do it. Got it. Different ways to increase
I'm glad that I'm clear on that. So hopefully, clear on
Hopefully,
that.
yeah, we'll find out.
Oh,
So another question I've always wondered is, I know you're responsible for the organ delivery system, or as you called it, UTDOS. Am I saying that right?
UTODS, Utah.
UTDOS. Okay. Um, how I know you're on the aviation side of things. How involved do you get with the organ? I don't exactly know what an organ, how an organ is packaged to deliver it. Assuming maybe it's on ice or something like that. Um, do you have to maintain a certain environment? Speaking for you directly and your team, does your team have to manage that, or does it come to you? Is that something that UT does on their end, and then you just focus on the aviation? Do you get involved in maintaining the environment of the organ itself?
Yeah, that's a good question. So we at the proof of concept level, for example, the September 2021 drone delivery of lung for human transplant in Toronto, that package was basically a standard, traditional lung on ice type of package. So we had to maintain, typically it's a 6 to 8 degrees Celsius environment throughout the transit of the organs. So that is really a donor organ scenario, right? Where you want to put the organ in a cold environment during transportation. Now, for the alternative organs or manufactured organs, there are several ways that these organs could be transported in the future. On the short term, for the Xenotransplant program, we have those organ care system devices that basically maintain the right parameters of the organ during the transportation. And it's more complex. It's not a passive system. It's more like an active system. It has larger volume. It's heavier than the primary packaging, for example, the donor lungs. So these organ care system are integrated into the aircraft. And there's some interfaces, of course, between my team and the work that happens in the aviation, on the aviation side of things, with the teams that are basically managing, for example, the xenotransplant procedures. So definitely we are interfacing aviation and the researchers down in Virginia as it pertains to the organ care system requirements. How best to integrate that into the aircraft. My team would not design per se those organ care system. We would interface with the team or the teams that are using it. Whether that's a investigational program or a clinical trial phase, for example, we would make sure to track down the evolution of the xenotransplant science and what is going to be ultimately the organ care system requirement that will be used for the medical cargo design activities.
Yeah, that makes sense. That makes sense.
But to date, we are very focused, of course, on the hydrogen electric and fundamentally speaking, the hardcore propulsion,
Yep.
design and certification.
Yep.
But we do interface as well for those organ care system integration into the medical payload area.
Yeah, that makes sense. That's kind of what I figured. I just wanted to ask because I don't know, my mind likes to imagine like, what does Mikaël have on his plate of responsibilities? And just certifying a hydrogen powered aircraft in itself is quite the endeavor. And so I always wondered, I wonder if he's tasked with that as well as keeping the organs maintained. It makes sense that,
Yeah. And I think that also for the cold storage scenario, basically there's a few areas of further research, that needs to happen. Whether some of those organs may be normothermic, so carried around at a typical human body temperature. Or maybe like at a colder level, in that 6 to 8 or even 6 to 10 sea level. So depending on those different scenarios and those different type of organs, I believe that there may be some clever ways to leverage a cryogenic liquid hydrogen storage cold source for some of these organ care systems. So in the future, there will certainly be more interactions on the fundamentals of the aircraft system and perhaps the organ care system as well, if we require to maintain a cold storage environment, for example.
Now, you literally read my mind as I was thinking, like, oh, there could be maybe some overlap and sharing of technology that might be valuable to both.
Definitely.
Yeah. So to come back to the hydrogen powered aircraft, let's say it's certified, FAA, on board, everything is working, it's safe. What do you see the biggest challenge being? If you had all of those things, what would your biggest challenge be?
You mean once it's certified? Oh, definitely the infrastructures. So how fast the hydrogen infrastructures will develop at so many airports, more specifically East Coast, East Coast US. I think that given the small size of the vehicle, roughly we require 20 kg of hydrogen, liquid hydrogen for 250 nautical miles emissions. So we're not talking about a big footprint for those hydrogen infrastructure. So I think that obviously we don't want to carry around hydrogen with diesel truck, that purpose. So we need those hubs, we need those hubs. And since we have a very precise concept of operation, because the origin and destinations are well known, is because, the locations where the organ are going to be produced and the destination hospitals are well known. So the flight routes are very well known, right?
Yeah.
It's a very defined and predictable concept of operation, and therefore we can plan for those strategically located hydrogen refueling hubs, if you will. At so many airports within range of the aircraft, typically 250 nautical miles. Definitely the key challenge, the number one challenge. I would say second would be actually that might not be that much of a challenge, but social acceptability about hydrogen flying vehicles. But given the nature of the mission, I think there's a lot of positive argument from a public benefit standpoint that we can bring to get to get social acceptability on our side much easier, I would say.
I think public acceptance is not going to be a challenge for your use case. How is anybody going to be a naysayer when you're saving a child's life, or saving somebody's parents, or it's like that, it outweighs everything. But going back to the question, and I kind of intentionally, I sort of knew what your answer would be, but I wanted to confirm. But this is literally the reason why HYSKY exists. So we tell people that because we started actually as a for-profit company that was putting fuel cells on drones, and we were flying with hydrogen, and we said this is the answer. And we thought, once we did that, the funding would rain down from the heavens. And it did not, because as we were pitching to investors, a question we were not prepared to answer was, they would be like all in until they would ask, so you guys have a reliable source of hydrogen? And we're like, well, not exactly. And so we kind of started looking into what that looks like. And we're like, wait, that doesn't really exist. And that's kind of a whole entire different business model. So then we started talking to other people that were developing hydrogen aircraft and asking the same question. And it turns out we all were sort of having this problem. So that's when we pivoted into the nonprofit space and we said, HYSKY will bridge the gap between aviation and hydrogen. And I want to introduce you to a company called Nova Spark Energy. And they're actually here in Houston. You actually did meet the CEO, Rick, but you guys didn't really get to talk. It was when we were in that picnic table and it was pouring with
That
rain.
rings me a bell, but yeah, we should
Yeah, you
follow
guys,
up.
yeah, you were sitting next to him, but what they're doing, and they're working with Department of Defense, and this is public, but they have an actually working system that it's a trailer, it's mobile, it pulls using all renewable energy, it pulls moisture out of the air, and it converts that moisture into hydrogen. So it literally makes hydrogen out of thin air, and it can make enough to power what you all need. They've got a system deployed in Hawaii right now. That department, they're funded by DIUX and some other folks. But they're a really great team, very ethical. They're like ex-Marine. I really like working with them a lot, but they actually have a working technology. Now, they don't liquefy the hydrogen. However, there's another company that we work with that uses a trailer and renewable energy, and you feed it gas and then it liquefies it. So with those two trailers, you could literally make liquid hydrogen out of thin air. Both of them work. Both of them are being used by the federal government right now. So they have working technology. So
Yeah,
TRL
I
level
like
is
the
10.
idea of mobile hubs or mobile trailers, at specific airport hubs. That is definitely, especially for smaller scale vehicles like Robinson helicopters, right?
Mm-hmm.
You don't require, again, that footprint that would be typically required for refueling an airliner like an Airbus 320, right? So,
Yep.
so I think that mobile way of thinking through the distribution and the refueling is a very smart way to start with.
Exactly.
And as the aviation industry sees more of it, I think then that will trigger perhaps more effort on large scale infrastructures going forward.
Yeah, exactly. Because there's no sense in going and building this massive like solar farm. And, especially when you don't really know how the industry is going to shape up, but having mobile units where you can kind of refine whatever it is your flight path or how much hydrogen you need until you build something more permanent. I've always been a fan of that idea, especially since I don't know if you've been following the hydrogen hubs in the US, which I
Yeah.
got really involved in the hydrogen hubs in about 2022 when I kind of around the time that HYSKY was founded, when I was realizing we sort of have this big gap where we're going to need green hydrogen. And I was a big advocate. I'm a huge fan. I was excited. Our US government is investing, 8 billion into production of green hydrogen. But then things are kind of in limbo right now, and nobody really knows what is going to happen with the hubs. I've heard that the red states will keep their hubs and that the blue states will lose their funding for the hubs. All of this is speculation. Nothing is certain. But still, even if they have their hubs or not, they're not producing hydrogen yet. They're still in planning phases. And I do hope the hubs keep their funding and they do get to go on to make hydrogen. But there are folks that need hydrogen right now, and it doesn't need to be, 1,000 tons a day to start. We need to start small, I think. And so, and anyway, my point was we were, every year we host what we call a hydrogen hub summit. And typically we would bring in the DOE funded hubs, but this year, none of them were allowed to speak. And so 2 weeks before the event, all of our speakers canceled, and I'm scrambling. But it's so funny because this happened organically. The defense funded hydrogen producers were reaching out to me and saying, well, we're making hydrogen right now. Why don't you just let us talk? And then it just kind of organically happened. And then we ended up having speakers that were demonstrating technology that was producing hydrogen right now and that you can purchase off the shelf. So it ended up being a really exciting event and like a last minute pivot. Anyway, I just keep thinking that is exactly the way to go, that it doesn't need to be so massive at the beginning, you know?
Exactly. Yeah. Yeah. I think it has to be tailored to some use cases that are going to be a catalyst for the broader industry afterwards. And I see definitely Unither and UT as being one of those key catalysts. So, and by the way, thank you for being a great advocate for those critical questions, and with DOE and all that. I think it's a very important thing to do, and it's a very important thing that NFP like HYSKY definitely need to push. There's a high value for all of us in that era. So thank you again for your work in
Well,
that.
thank you. Thank you. I anger a lot of people, but it's for the right reasons. And thankfully, you know, I'm in a position where I'm, you know, not associated with the government. I'm not associated with Department of Defense. Our goal, High Sky's mission, is to advance hydrogen aviation. And that's what, you know, we aim to do. So I am in a sort of a unique kind of privileged position where I can say some of the controversial things that others can't say because of, you know, their role or their job or whatever. But I think it's safe to say that the hubs in the United States, at least the DOE funded hubs, they are in jeopardy. And I think there's a lot of activity and a lot of partnerships that came out of them, but we can't just solely depend on that. Of course, we'll continue to follow and participate and collaborate, but kind of to, you know, UT and UB's motto, one goal, many shots. And so looking at alternative ways to get hydrogen is going to be really important.
Absolutely.
Yeah. You know, I wonder if, well, let me ask you this. Do you think that it's possible for an airport to pivot to hydrogen? Something that I think is like, how would like a hub like DFW, how would they integrate hydrogen? You know, like we say, like they may start with ground vehicles, but if you really wanted to transition to a hydrogen powered aircraft, I feel like you would have to either build like a new terminal or shut down existing operations, which would maybe collapse the entire global supply chain. So like, what does that even look like?
Yeah, well, I'm not an expert in a large-scale airport H2 infrastructures. I think there's a lot of people looking into those very challenging questions at the moment. I can, however, speak to our local experience because we are implementing liquid hydrogen on a Class G airport in Quebec, Canada. At the end of the day, I think it's a lot of effort to be done in terms of making sure that the physical separation and the mitigations that have to be put in place to safely operate that infrastructure, whether that's from a supply perspective or refueling activity perspective. So defining a right standard, a consensus standard on how to refuel and what are the constraints that pertain to that. I think there's only a handful of people in the world that refuel liquid hydrogen in recent years. I mean, on small scale or medium size aircraft vehicles. Of course, I'm not talking about, the space shuttle and all those larger programs. I'm really talking about, smaller scale aircraft prototypes. So the lack of standards and standard operating procedures on how that refueling will look like, how long does it take? How long it takes largely depends on the specific hydrogen storage technology you're using on board the vehicle. So I think all those questions are still pending, and that will inform how best to integrate that infrastructure in an airport environment. We are in the process again of doing that in a Class G airport, so it's nothing like a controlled airspace,
Sure.
large international, high traffic density type of airport. But still a lot of learnings and a lot of helpful processes to help informing the refueling procedures and how that can be scaled at other airport where the environment might be more complex. So I think the industry has to collaborate in terms of the definition of those standards, and that will dictate a lot how best and to operate and integrate those refueling equipment on airport sites.
Yeah, that's a great answer. Very interesting. Maybe you'll help me get Val from Zero Avia. I would love to have him on the podcast. I think that's probably an area he's looking at more than you and I. You said something like a smaller, not as busy airport. I've often felt like one of the things HYSKY does is just we're always looking to chat with airports, especially smaller airports. A lot of them are part of an economic development program for a city. So they may be funded by the local government and things like that. And smaller regional airports, I have found, are very keen to learn new upcoming technology. They're very open-minded around air taxis and hydrogen. And I've often thought there was like this huge opportunity, and anybody that hears this, please take this idea because I don't have time to do it. But I think there's a huge opportunity for somebody to start a hydrogen powered airline and then launch out of regional airports. I think it would be so difficult to get like DFW and LAX and those sorts of to have like these, I don't know, 20 passenger, 200 passenger hydrogen powered flights, like say, 8-320 or 737. But a regional airport, and a lot of the regional airports, they have the runways to support those aircraft. I think there's just like a huge opportunity if somebody could be very patient, like 10, 20 years to start a hydrogen powered airline at regional airports,
Yeah, I think that's a great idea. I think at the end of the day, I think it's what is the infrastructure look like? How much does it cost? So what's the capex?
Yep.
And what's the opex? And what is in for the airport or the FBOs, right?
Yep.
So is there a business model right now that could be presented to those FBOs at regional airports, perhaps, that basically would result in some revenue streams for them as they host hydrogen-powered aircraft and VTOL or helicopters? And what's their markup, for example, on the hydrogen that is being distributed there, similar to when they sell jet fuel or so. I think there's a bit of work to be done on the capex and the opex for those infrastructures and what is going to be appealing to FBOs and airport operators going forward, and start to pique interest of people, and perhaps as they see more operators interested and more companies like UT interested in the space, they could move on quicker sooner than later.
Yeah, I agree. Okay, so now I'm gonna pivot something I didn't tell you we were going to talk about, but something that I love to do on these podcasts is try to get to know the person behind Mikaël Cardinal. So I would love to know about your childhood, your parents, siblings, if you have any, where you grew up, kind of what makes you who you are. Where were you born? We'll start there.
Perfect. Yeah, so I was born in Gatineau, Quebec. So that's close to Ottawa, the capital city of Canada. I wasn't basically, I didn't grow up there, though. So when I was 6 months, my parent moved to Quebec City. So Quebec City is really where I grew up. And I'm the oldest of a family of five. So we growing up, we were quite intellectually motivated to pursue studies. And also, I think that a lot of my personal ability to focus and aspire to new things really came from my education in classical piano, where I was drilled for so many hours, playing those Ballades de Chopin or Debussy or other well-known, classics. So I even competed at the provincial level at some point. So yeah, I think that personally, most of my education around science and music, so developing both my creative and more rational aspect of my brain, ultimately I think brought me a lot of very good skill sets. At a time where I wasn't exactly sure if I was to be like an engineer or pursue like a career in music or whatever. But yeah, fast track now college studies, computer science. I knew quite rapidly that I wanted to be an aeronautical engineer. Because just of my passion, everything that flies in the third dimension always impressed me. At a very young age, I was like going to air shows and seeing those flying objects. Was just so appealing to me in terms of not only flying them but trying to understand how they work. So what's in the cockpit and what's in the power plant, and so got exposed to a lot of air shows in my youth. And that explained, I think, partially why I was brought to aeronautical engineering. So yeah, so fast tracked. So college, computer science, a couple of years in Quebec. We call it it's natural sciences, but it's I guess the equivalent of U.S. computer science. And then was accepted in a couple of universities. Decided to accept a restricted program in Sherbrooke. So Université de Sherbrooke, Eastern Township. So that's an hour and a half south of Montreal. So did my mechanical engineering degree, undergrad, and then did a major in aeronautics under that mechanical engineering undergrad program. Did a capstone project on some composite wing design for general aviation, a Part 23 aircraft in collaboration with the industry. So, got exposed slowly to general aviation, and then some internships and co-op under a co-op program. Worked on very neat technology such as a spacecraft with MDA satellite in Montreal, as well as other project or research project with the Bombardier. So yeah, so really got passionate about aviation more specifically during my undergrad, and then during my master's, of course, working on some high fidelity dynamic modeling for UAVs. That was one of my area of expertise during my master's. So really got passionate about flying things and designing things that fly, flying them myself ultimately.
Yep.
Yeah, so that's a bit about myself. Always been a passionate about art and technology. And I believe that technology development can be art in some ways. And I'm really excited about bringing those two areas of my brain into everything that I do.
I'm smiling so big because I was just talking to my daughter and my niece about there's this overlap of brilliant people, brilliant engineers and scientists of art, creativity, and math and science. And you probably know Martine has a deep music background. John
He does.
Piasecki has a deep music background. I don't think I've ever met a brilliant engineer that didn't have a deep music background. And I also have a deep music background before I did aerospace engineering. By the way, my degree was basically exactly what you did. It was like mechanical engineering with a focus on aerospace engineering, we call it in the US. So very similar. But before that, and I wasn't trained on piano, but we had a piano in our home that I liked to tinker on, and I taught myself how to play. And then I ended up going into band, and I played clarinet, and I was first chair, and I competed and just naturally picked it up.
Mhm.
And was good at math, but always conflicted about should I do math or music. And I think when we're younger, we think that they're different. We don't really understand that they are very complementary. But I pursued the music path. I was signed on a record label. I rapped, played guitar, ukulele, piano, and I still play music. But I can tell you, picking engineering first was probably smarter because the money was not there musically. The the I guess the street cred and the YouTube views and things like that were there, but keeping the lights on was very challenging. And so in my 30s, I decided, okay, I'm going to go back to school. And so I didn't even go and get my bachelor's until I was in my 30s. But it wasn't until I was in an internship and I was working in a lab at it was an aerospace company that did a lot of like electroplating and things like that. And they bought this spectrometer. I think I'm saying that right. But anyway, it measured, they had never had one before. And I was running the lab as an intern. Don't ask me why. I was doing all kinds of dangerous things that I shouldn't have been doing. I was having the time of my life and I was in there by myself playing music, doing whatever I wanted. But so they get this machine. It's like this $30,000 machine. And they're like, Danielle, figure this machine out. I'm like, the heck is this thing? So I'm reading the manual. I watch a couple YouTube videos. I get it set up and I start sticking different chemicals in there and it just like measures the light, the frequency that the light bounces off of it. And then you can
Mhm.
identify which chemical it is by the frequency that you see and by the waves. And within like an hour, I was like, oh, this is music. This is
It
music.
is.
And
It
I
is
was like,
music.
oh, I get frequency because I've mixed. I also produced my own music. And so like I've looked at waves so much and like I got it immediately. And that actually got me a good raise. But I thought I was like, this is music. Math is music.
Of
Math is
course.
music.
Yeah, sound
Yeah.
waves, and you when you understand the frequency and time,
Everything. Yeah.
transform back and forth. Well, when I learned synth, right? Because beyond my classical piano degree, I afterwards I learned synth and sound design,
Yeah.
and I do that as a hobby, here and there. But yeah, you're absolutely right. How we design sounds in a digital world, and whether you're using acoustic piano, acoustic guitar, or whether you're on a synthesizer, those waves and how we process and how the human ear perceive that is all signal processing, right?
Yep.
And I found that the creative aspect of me and the engineer of me in me really met um, at the intersection of those two fields when I started that synth exploration and sound design. Actually,
Do you have
and
anything
it,
publicly available?
no, not really, not at this.
Come on.
Yeah, maybe
No.
very very soon. Maybe
Okay. I'll be very interested in hearing that. I will definitely follow. I'm just like an analytical person, but when I sort of am a fan of someone, which I am a fan of you, you're welcome. I like to understand them fully. I do this with Martine. It kind of freaks people out sometimes because I think if they don't know me, maybe I come across as like a CIA agent or like, why, Danielle, why do you know all this about me? But I just like I want to understand how people's brains work. And it's just, I don't know. I'm also neurodivergent and it helps me like connect with people. So I would love if you would at least make a video of you playing piano. I mean, especially if
Okay.
you're classically trained. I found a video of Martine playing piano. She probably doesn't even know I found
Yeah.
it.
And flute and
Yeah, and flute. I
sometimes
have that
bass,
album. Yeah.
bass actually.
Yep. Uh-huh. And so, but it's like, it's just very interesting to see how human somebody can be. And I mean that in a good way because like it's magical. It's like, yeah, we can create and do math, and some people think, wow, that's rocket science, but then you also can create. It's just so freaking cool. So I'm not surprised that you have musical talent, and I have no doubt that you're very talented because I can tell you're a perfectionist and you probably won't release anything until it's perfect.
Yeah. Yeah, that's true. That's true. But sometimes it has to be felt, you know. So you need
Yeah.
to feel it, and when it's raw, I think it can convey even a stronger message sometimes.
Oh yeah, for sure. Do
Like
you
a
have
live performance versus studio work that takes so many weeks, right?
Yeah, exactly. Well, and I'm the same way. Like if I'm in the studio, sometimes I'll feel it, but I'll want to perfect it, but then I might perform it live and I might completely mess it up, but for whatever reason, the audience really liked the way that I did it. It was more authentic,
Mhm.
and yeah,
Yeah.
we need to have like a UT High Sky music fest or something where everybody plays their instruments. That would be so cool. We just all Rachel's in the band too.
Oh
She
wow.
plays, yeah, we used to jam out all the time. Oh my goodness. So we would play guitar and ukulele and sing. She's really good at harmonies. She's a drummer. So yeah, all of our happy takeoff days were very filled with music. Does Sarah do music?
Yes, a bit of singing and piano playing as
That's
well.
so cool. I love it. Yep. Yep. It takes one to know one. I am not surprised by that. All right. My last question I'm going to ask you, Mikaël, is what what advice do you give your 18-year-old self?
Hmm. You caught me off guard
I
here.
know it.
Um,
Got to be authentic. That's why I don't tell this in
yeah.
advance.
Pursue your inner passions. Don't be distracted by what other people think of you.
Brilliant.
Yeah.
Brilliant. I have to remind myself of that one often. Yep.
Yeah.
That's good.
Yeah. I think we all need to um, remind ourselves about that.
Yeah.
Sure.
Yeah. Well, Mikaël, I feel like I really got to know you over this. We've crossed paths so many times, but we've never got to sit down and talk for almost 2 hours. I am very honored. I thank you so much for sharing everything, being open to all of my questions, and I just can't wait to support and promote your work further.
Well, thanks to you, Danielle, for the opportunity to share a bit more about what I'm doing for Unither Bioelectronics in United Therapeutics. Thank you for your support. Thank you for your commitment to hydrogen aviation, and we'll certainly be in touch for the next flight demonstration and the promising infrastructure work that has to happen to make this a reality for the greater good, actually. So,
Yeah,
thank you for your work.
absolutely.